Okay, guys, so now that we reviewed one and two step equations, we're going to move on to where we have variables on both sides of the equal sign. Again, totally review, as is a lot of the things you're going to see in this unit. So I would pause the video and try this little warm-up, solving a two-step equation. Okay, and then I would go ahead and solve it and come on back. Okay, the first thing you're going to do is subtract 4 from both sides. We always start with the addition or subtraction when solving an equation. Then we have 1/8 times x. So I'm gonna actually write this as x over 8. It's a little bit easier to see. Equals positive 8. And then I'm gonna multiply both sides by 8 because this is division. And I get x equals 64. All right, so we didn't look at any of these yesterday, but sometimes you have like terms on one side of the equal sign. So if this says, which is the correct way to simplify this given equation, and then it's a multiple choice. So hopefully you remember that before you can even solve for a variable, you have to combine your like terms. So here, I'm going to put it down at the bottom. We get negative 14x. Okay, we've already talked about combining terms this year, so hopefully that's familiar. And then the 7 and the negative 4, which is positive 3. Okay, and that equals 18. And now it becomes just like what we did in the warm-up. I'm going to subtract 3. Well, it doesn't say to solve. I could keep going and solve this, but the question just asked what's the first step. So negative 14x plus 3 is the correct way to simplify this. If you actually go ahead and solve this, you end up with a decimal, which is fine. Decimals are fine, but the question did not ask that. Okay, so I would pause the video. These are 2 more to try with combining like terms before we get to the variables on both sides. I'm going to pause this, do them, and hopefully your answers match. Okay, so for the first one, you should have gotten x equals 4, and the second one, x equals negative 3. For both of these, you can still check. Okay, I showed a quick little check. This time, you just have to make sure when you check, you're plugging into the 2 variables. Okay, so variables on both sides. Okay, literally, there's a letter on both sides of the equal sign. So that's what both sides means. Okay, here's the equal sign. Okay, we've got an x on each side. So hopefully, again, this will come right back to you as you see it done. Okay, so the best thing to do when you're solving an equation with variables on both sides is locate the variable with the smaller coefficient. So we've got a 5x and a 3x. 3 is smaller than 5. So I'm going to start there. I'm going to do the opposite. Okay, so I'm going to subtract 3x from both sides. So that gives me 5x minus 3x is 2x minus 4 equals 2. Once I do that, it becomes a 2-step equation. So hopefully not stressful. I'm going to add 4, because I always start with the addition or subtraction first when I get to this point. 2x equals 6. Divide by 2. So x is 3. Right? For this one, I'm going to show the check. Okay, again, this is something that you should do no matter what. Okay, it's just such an easy way to see if you got it right without even doing much work. I'm going to plug in 3 to both sides where the x is. I'm just doing substitution. And I'm going to take a look at the left side of the equation. I have 5 times 3, which is 15, minus 4, which is 11. And then the right side, 3 times 3 is 9, plus 2 is 11. Again, you can put all that in your calculator. And it checks, so I know I'm right. Okay, so this one, I locate the variable with the smaller exponent. It's right here, so I'm going to subtract 6y from both sides of the equal sign. I get 10 equals 4y minus 12. Okay, and now I'm going to add 12, so 4y equals 22. And I'm going to divide by 4. Okay, and you can put the decimal answer, whatever 22 divided by 4 is. Okay, I'm going to actually just make it a reduced fraction, 11 over 2. Okay, either answer is fine, a decimal or a fraction, whatever you're more comfortable with at this point. Okay, so let's take a look at this one. Again, I'm going to locate the smaller variable, so negative 2a to both sides. essentially you can do either. I could start with the 7. It's just sometimes that creates a little bit more negatives than we might want to deal with. Okay, so I get 5a minus 10 equals negative 6. I'm going to add 10 to both sides. So I get 4 equals 5a. I'm going to divide by 5. Okay, so you can keep it as 4/5, okay, or 0.2. I'm sorry, 0.8, not 0.2. 0.8 as a decimal, okay, whichever you are more comfortable with. All right, so this one just has a decimal in it, no different than any others. I'm going to do this one fast. Okay, subtract 2n, I get n minus 5.4 equals 1. I'm going to add 5.4, and when I do that, I get 6.4. All right, so with this one, all I did was not only have variables on both sides, but now I'm going to combine some like terms first. So 7y and negative 3y is 4y. And then I have 5 and 4, which is 6, equals 2y plus 2. So now I can subtract the 2y. I get 2y plus 6 equals 2. I'm going to subtract the 6. I get 2y equals negative 4. Divide by 2. So y is negative 2. Okay, so sometimes there's special cases, and this happens sometimes, not often, but I want you to know it. Okay, I have the same variable here, a b and a b, and they're both positive b. So what happens is no matter which one I start with, okay, if I subtract b from both sides, I end up with just negative 6 over here and negative 12 over here. The variable dropped out on both sides, okay? So we can't have that. That doesn't make any sense because negative 6 does not equal negative 12. So what you say here when that happens, when both letters drop out, you say no real solutions. Again, it's not going to happen often, but I do want to show it for you guys. Okay? And then this one here, okay, I'm going to combine my like terms on this side because we have to do that before we can do that. I end up with the same equation, 6x plus 2 equals 6x plus 2. So again, if I use my method, minus 6x to both sides, I get 2 equals 2. But those are the same numbers, okay? 2 does equal 2. So what we say here is all real solutions. When the numbers match, it's all real solutions. Okay, so go ahead and try these. Pause the video, try them on your own, and then see if your answers match mine. All right, so hopefully you got these answers here, x equals 3 and x equals either 6/5 or 1.2. Again, whichever form is fine with us. Okay, so go ahead and try the delta math, and hopefully it's not so bad.